Hello everyone again to my YouTube channel. Today in this session I will continue to show you how we can save in our model after training or prepared or when we found in the best parameters for our model. Uh, as we see before, we implementing a model with a PyTorch. Okay, well I'll show you what we do before. Okay, using this PyTorch, we are building a model. Okay, we building this model using a random data. Sorry. So this is a model y equal to y times x plus y. So the goal here is to find the best parameters of y and y. Well, after training of our model, so this is the picture before trying to train our model. So here in this dot point or blue point here is to train it, and green point is for prediction. Well, here after our after prediction, so without trying to train our model, this is the result what we get here. We're trying to predict this green point here in our or using our model in PyTorch. Well, so after the result, we measure the distance between the prediction point and the origin points, and this is the result, or this is the distance between all these points. Well, the third phase we do here is we try to train our model using this last function that epoch uh, forward our data. That means to give it for our model the input data, trying to measure all the data and to find the minimum global minimum, the minimum errors for all these points. Well, after that, using just here we using 100 100 epoch. Okay. Well, I will show you now something other totally different. Here, after all these things, we measure the loss function here. Let me see here in trained and test data. So when increasing the number of epoch here, the loss function or the number of error or the distance between the predicted points and the origin ones is decreased also. And this is the goal. Well, after all these things, when uh, sending the model to trained, okay, we trained the model, and this is the result what we get here. So the distance between these red points and the green points is minimal, okay, compared to the first one before trying our model. So today I will show you how we can save in our model. Of course, when we tried our model, when we found in the best parameters for weights and pies. So based on this example, we need to save it to work with in the future because some data when coming in the future we need to use this model. Well, to save model here with a PyTorch, the first thing we should do is to import this path lib, import path. Okay, from this path lib on the package, we import this function of path. Well, the first phase is to create a path, model path equal to path, create a directory called models or the name of models. When we're using this model path dot mic direction or mic directory here, this function, and we give the prompt, of course, is truth and exists. Okay, so we try to create this root. Well, the second step here is the name of our model. So I give a name for my model here, 0.torch workflow. So this extension is very important, PTH, path. Okay, we have a pickle when we're working with a scikit-learn, and when we build the model using scikit-learn, if we want to save in our model also, we can make it as a pickle. Okay, here in PyTorch, we're working with PTH, so I save this model in this path. Okay, model save path equal to model path, this model and model name inside this. but I give it this. I I record or I save this name of my model. So when I save this model, so this is a message. Message tell me the name of my model is saved is the in the root what I create. Okay. Well, if I want to reload my model again, I will instantiate a name from this linear regression I created before. Okay. So this loaded me the this loaded model, this version of this model. I will give it this path because this parameter it will be replaced inside of this instantiate I create based on this linear regression. Okay, to paste values for ways and bys it will be replaced in this version. And also here we are making our model in evaluation mode for prediction. Okay, so that's what I do. Loaded model 0 equal to evaluate to make my model in evaluation mode. When I making a prediction with the syntax with torch.inference mode. Loaded model price equal to loaded model 0 text. So in this case, I want to predict again the X test data. Well, here I will making a comparison between my predicts and the loaded model rates here. So it should be equal. Okay, here that's what they found. That means when I load in my model again, if I work with, I will found the same result. That's what I have here. That's what we see. We compare these results between old one and when I load it or I instantiate a new version from my model. And all this test is true. That means we have the same results. Okay, so let's continue. Here, what I will do here is to activate the device because as we know in deep learning especially we need a device. We need GPU and CPU to make those operations. We matrices and the vectors we have. Because in the end, no network is just high dimension operation between matrices and vectors and functions. So for this, we need to work with a CPU, GPU to make this operation more faster. So that's what I do here. Because I work in my local environment. I activate the CPU. So here I activate the CPU device equal to CUDA if Torch CUDA is available L CPU. So here in my laptop this CUDA is not available, so for the reason I will replace it with CPU. Okay, so my device here in CPU. So what I try to do now, I want to increase the number of epochs. So if you remember, number of epochs does mean how much of forward of data it's coming when I send my data. How times it's passing in my model to updating or changing update the errors of those functions. Well, at this time I will increase the number of epochs. So that's what I do now here in this piece of code. Just I do the same things. Okay, I initialize my variables weights of values with the random values here, and they create same values here. So like before, okay, this is the random values. Well, here also I split my data to train it and test. Okay, and here I use also this function that I will create pulse prediction to predict my data and see it here. In scatter in this straight line of green and blue points. Train and test data. Okay. Well, the next phase here is to create my class of linear regression. Okay, I do that before. Okay, so I create here the number of features, output feature. We have one feature is this I see y equal to y times x plus y. Does mean we have just one feature, one independent variable or one independent feature, also one target. That means we have one feature and one output. Well, also here I created forward because that means when I send the X here is uh, is considered like input data. Okay, here I implement also one version model to equal to linear regression feature because here I create again a new version, a new class of my linear regression here. Also, I measure the parameters of my model here as we see. Okay, so we have here tensor, mean weights and bias here. Okay, just what I do here, I try to port or import all these operations to send it to my CPU to make those operations more faster. That's what I do because I want to incorporate a number of ports. Well, here I will check my device here again. It's a CPU. Okay, all these things is happening in CPU. Well, so here I want to pass this operation in my CPU model 2 to the device. I will send all this data of my model 2 to device. That means CPU in this case. Well, we will check again if also those operations is still also in the CPU or not. Here, what I do is I create my own malloc functions. That means the measure distance between the predicted point and the origin ones. So using this loss function. Well, also here I applied my optimizer. That means the steps what I need here to update my model. So in this case, we have model 2 parameters and we have learner rate equal to 0.01. That means the steps I need to update my data. So here if we see here we have the number of push 1000. It's not 100. Before we trained our model based on 100 epoch, but this time we have 1000 epoch. That means uh, we have the ability to make more model is more based than before. So the same thing is happening. We have number of epoch here. I have trained and test data. I pass all these things as I did before in device. That means CPU. I trained my data for all these epoch we have here. Okay. Also here I make my model here in the forward pass. I mean we have y product equal to model 2 x3. Okay. Again I calculate the loss function so between the predicted point and the origin ones. Also I apply my optimizer here. Okay, optimizer that means if we have one epoch for example pass for first time we make summation of all the parameters when then we make it a zero again to refresh and make other epoch. Here we have the loss backward. That means when we predict and measure the distance between the origin points and the predicted point, we go back to reduce or to minimize the error. Here I apply the step of my optimizer. That means the learn rate. Sorry. Here also I make my model in evaluation mode to make it the prediction. Here I make the prediction here with torch inference mode. So my model or test produces model to X test. And I measure the distance between test predicted and the origin ones. Here this is my epoch 1000 epoch here. For each 100 epoch I show my loss function. So here as we see after 1000 after 100 after 200 epoch the result is still in the same value here as we see. That means this is max. Okay, so this is max or the base time we can cover with number of epoch we have. So here I print my weight value here it's 0.76 and for bias we have 0.83. So this is the first values. and this is the origin ones. We have 0.7 for weights and 0.3 for YEs. So we look now the difference how it is between the YEs and weights based on the origin and the new one after updating the, these parameters, those parameters. Well, so we making the prediction here. We make my model here in evaluation to make it in prediction. Prediction, sorry. This is the result. This is the result here what we found. And when we pass this predicted point in my plot function, this is what we have the read point in the same place of main point. That means this tank we have here. That means my model is very trained and I found the best parameters. Okay, we have a read point in the same line of these blue ones. Okay, well, I create a directory of the okay because we are saving our model after we train it with 100 or 100 epoch, but now when we found the best parameters with 1000 epoch, I need to save it again. So this is the same steps here. I created a path, I save it. Okay, and this is the result here, the best model here, as we see here. It's great. Um, so we are saving my model. I loaded my model again. So the same phases when I try to make it evaluation mode to make a prediction. I get the same result. That's mean true. That's mean I conserve the best parameters of my model. So at here I will end in my tutorial. I hope that is clear for you. And I will put the link of this tutorial in my description to my GitHub. So if everyone is interested to discover this piece of code, it's available in my GitHub. Happy learning for everyone again. See you again. Bye bye.